In this video, I want to talk a little bit about implications and show you an example of my own thinking that's outside of the book that might help you understand some of the weirdness with implications. So I have two big points I want to make here. Well, let me first say implication. Again, make sure you watch or read through the text first before watching this video. If you haven't yet, pause and read through the text and then continue on. So implication, this is another way to combine statements. So if we have statements and open sentences, we can also combine open sentences, statements. Let's say we have statements P and Q, then we can form the compound statement P implies Q, or if P, then Q. So this is a new statement that has its own truth value based on the truth values of P and Q. Right, so this is an implication. I have 2 points here. One is that it's not commutative. That is, P implies Q is not always the same thing as Q implies P. These are not always the same. And the second one is that it's this weirdness, and you may have missed it in the text, but if you caught it, maybe you thought it was weird that if P is false, then P implies Q is true, regardless of Q. So regardless of the truth value of Q, it could be true, it could be false. I don't care. If P is false, then the implication is true. So there's these two bits of weirdness that I'd like to talk about and illustrate. So the example that I like to use here is kind of inspired by where I went for my undergraduate career. So when I was a college student, I went to Northern Michigan University, which is in the Upper Peninsula of Michigan. So this is distinct from the Lower Peninsula of Michigan. And there's two ways you can get up to the UP, the Upper Peninsula, either by going across the Mackinac Bridge. So let me maybe do a little sketch of the Upper Peninsula. I'll try my best. We have the Keweenaw Peninsula here, something like this. And then a little sketch of, here we have Traverse City, and then it comes up to Grayling and Gaylord. We have the thumb of Michigan. So there's my rough sketch of Michigan, and here we are down here in Fort Wayne. So where's Fort Wayne? Maybe somewhere around here would be Fort Wayne. And I lived in near Ann Arbor, Michigan, where my parents were, and Marquette is up here. So in order to get there, I had two options. You could either drive all the way around, go through Wisconsin, and make your way up into the UP, or what I would do is come up and cross the Mackinac Straits and go up to Marquette, Michigan here. This is Marquette. All right, so why do I point this out other than to just tell you a little bit about myself? Right here, in order to cross the Mackinac Straits, you need to cross the Mackinac Bridge. Mackinac Bridge. Now, the Mackinac Bridge is a toll bridge. One way to think about a toll bridge is that it's a device by humans to enforce an implication. What's the implication here? The implication is, if I cross the Mackinac Bridge, then I pay $5. And this went up in value. It used to be like $3.50 when I was first going to college, and 4 years later it was $5, something like that. I think it's still $5. I'm not sure. Anyway, that's beside the point. My point is that a toll bridge, the little toll booth that happens at the end of it, enforces that this implication is true. Always. Namely, if I cross the Mackinac Bridge, then I pay $5. So here we have our hypothesis. I cross the Mackinac Bridge, that's like our P, and our conclusion. I pay $5. That's like our Q. And so we have here the implication P implies Q that the toll bridge is enforcing. Now, again, I'm using this example to illustrate these 2 points. So I want to think about what would Q implies P be. So P implies Q is true here. It's enforcing it. I assure you, if you cross the Mackinac Bridge, then you will pay $5. So what is Q implies P? This would be the statement, if I pay $5, then I cross the Mackinac Bridge. Right? So a good way to think about implications is cause and effect. If I do cross the Mackinac Bridge, then because of that, I have to pay $5. Cause, effect. Q implies P. Q would be my cause and P would be my effect, and I'd have to think about, is that true here? So if I pay $5, does it necessarily mean that I cross the Mackinac Bridge? Well, no, there's lots of instances where I've given someone $5, say at a store, and yet I don't magically cross the Mackinac Bridge. It doesn't necessarily follow from me paying $5. Another way to say that is paying $5, it's not sufficient to cross the Mackinac Bridge. I also have to be driving over the Mackinac Bridge. Then if I give them $5, I'll cross the Mackinac Bridge. So this is false. There's lots of instances where you pay $5 and you don't cross the Mackinac Bridge, right? That would be a silly cause and effect relationship here. So there's my first point illustrated. So this is not a commutative operation. Again, don't take for granted these laws. Just because we have some new operation doesn't mean it's going to obey the same laws as the old ones. And then the second point is this. Yeah, if P is false, then P implies Q is true regardless of Q. So let's pretend that P is false. So let's pretend that I do not cross the Mackinac Bridge. And the question is, if I pay $5 and if I don't pay $5, does that have any effect on whether this implication is still true or not? So, right, one way to think about this is, how would I disprove if you were like, no, Professor O, I don't believe you. I don't believe that this implication is really true. How would you demonstrate that to me and prove your point to me? Well, you would have to cross the Mackinac Bridge and not pay $5. That would be how you would disprove this to me. This implication would not be true in that case, right? It wouldn't have the cause and effect relationship because you didn't pay $5. Now, if you claimed this is false and you said, well, it's false because here I am sitting here, I haven't crossed the Mackinac Bridge, but I also haven't paid $5. Well, that doesn't really tell me anything about the implication. You haven't satisfied the hypothesis in that case. So this is really what this is getting at. P being false means the hypothesis has not been satisfied. The cause has not happened. And so whether or not the effect happens, well, I don't care about that, right? I'm telling you what this statement is saying is that if the cause happens, then the effect must happen. If the cause doesn't happen, it doesn't matter if the effect happens or not. This implication is still true in that case. All right, so I hope that maybe clears it up a little bit. Hopefully someone asked this in class, we can talk a little bit more about it. But these are two sort of weirdness things with implications that I just wanted to go over in a little bit more detail. Okay, that's it for this one.